Okay, let's do a problem about circular motion. So this is going to be circular motion. And we have different kinds of motion. Remember that if we go from point A to point B, this could be linear motion right here, or it could go this way from point A to point B, and that's linear motion too. Or you can move in 2 dimensions like this. This could be X and this could be Y. So you go from point A to point B, and this would be motion in 2 dimensions. So this would be linear motion. This would be linear motion, and this one too is linear motion, but vertically. And this one here is parabolic motion. So this is parabolic, okay? Parabolic motion, and this parabolic motion is in 2 dimensions. And so you have a circular motion, which is this one right here. So this would be your circular motion, okay? And we have other kinds. We have oscillations and other kind of motions, but this is what we're going to talk about, circular motion. So our problem goes like this. Let's say we have a particle. So let's have a circle here, okay? Right there, you got your circle. And let's say your particle is moving. Your particle is moving, okay, here. And I'm gonna do the velocity. This is gonna be your velocity right here. It's gonna go this way. It's gonna go up. So what do you have here? You have a velocity vector. Then you have another velocity vector over here. And you have another velocity vector here, and so. You get the idea right there. This is the center, and this is going to be your radius right here. This is going to be your radius, and the velocity is going to be constant, okay? Velocity is going to be constant, and the radius is going to be 1.5 meters, and the mass of your particle is going to be 2 kilograms. The mass is going to be 2 kilograms. And because this particle is going to be moving in a circle, it's right here. It's the one right here in the red. And that particle is going to be moving all over the place. But the motion of your particle is going to be in a circle, like you can see right here. So you want to find the centripetal force. So let's find the centripetal force. What is the centripetal force? Centripetal force is the force that points towards the center. So it's going to be the centripetal force, and it's always pointing towards the center. Here's your centripetal force, the one in the blue. That's your centripetal force. The one in the blue is your centripetal force. Okay, so how do you find the centripetal force? Well, the centripetal force is equal to the mass times the acceleration, and that's the second law of Newton, which you have to apply in this problem because things are moving with some acceleration. Okay, but what is the acceleration? The acceleration in this problem is going to be the velocity to the square over the radius. That's your formula for the acceleration. And this is going to be the centripetal acceleration because it's an acceleration that's pointing towards the center. Now, because the particle is moving in a circle, you have another formula which relates the linear velocity with the angular velocity. So this is going to be your angular velocity. So this is going to be your angular velocity. And V is going to be your linear velocity. There you go. And R is going to be the radius. Okay, so you got your radius. And let's find the centripetal force, which is the force that points towards the center. Okay, so the centripetal force is going to be equal to the mass times the acceleration, but the acceleration is going to be V to the square over R. And then you have the other formula which says that the velocity, the linear velocity, this is the linear, okay? The linear velocity is R times omega. And we know that r is the radius and omega is the angular velocity. Okay, so let's plug it in here. So the centripetal force is going to be the mass, and then it's going to be r omega to the square divided by r. So that's going to be the mass times r to the square over omega to the square over r. So this square is going to cancel with this guy, with the r in the bottom. So you got mass r omega to the square. So your centripetal force is going to be equal to the mass, which is 2 kilograms, times the radius, which is 1.5 meters, times omega to the square. And we haven't said what is omega to the square, so let's put it right here. So omega, I'll put it over here. Omega is going to be the angular velocity, and in this case, it's going to be 3 radians per second. So our omega is 3 radians per second. So remember that omega is the angular velocity, and the angular velocity is 3 radians per second. Okay, so it's going to be 3 radians per second. But you got to square this because the formula says that you got to square it. So the centripetal force is going to be 2 times, this is going to give you 3 kilograms meter, and you still have to multiply by 9. Radians have no dimensions, just you can get rid of the radians. This is going to be 9 over second to the square. Okay. So your centripetal force is going to be 27 kilograms meters over second square. But kilogram meter over second square is Newton. So this is going to be 27 newtons. And there you go. You have calculated your centripetal force. Your centripetal force is 27 newtons. Remember that all the forces are measured in newtons. And this is a circular motion problem. There we go. Thank you, and we'll do more of these.